All right, hello everyone. Today we are going to be talking about Python 4. So if you've seen our first 3 Python tutorials, we've basically covered all the basic concepts of Python, from inputs and outputs, print statements and such. We went into conditionals, we talked about loops, we talked about functions, we talked about classes, and now we're going to get into more advanced topics. So in Python, you have things called dependencies, and some of these dependencies can do fancy things. One of the most famous ones is called NumPy, or Numpy, if you want to call it that. Numpy is a math software or a math dependency or a math library in which you can go ahead and just disable waiting room.
Hello.
Hello, hello. Welcome, welcome. I'm recording, right? I am. Okay. All right.
Not much people, sad to say.
Not sure. Okay. So as I was saying, one of the most famous libraries is Numpy, which Numpy has a lot of libraries and in internal libraries that allow you to do a lot of math functionalities, but we're not talking about that today. We're going to be talking about tkinter and socket because that leads into a discussion of what the Hyperloop UI is like. So we're not exactly going to be coding that today, but it's going to be close. And we're going to go over the basic Hyperloop architecture as well after we go ahead and code up all the software. The prerequisites that you'll need is a basic understanding of Python, but it's okay if you're new to Python. We'll go over like the basic concepts of it. And if you have any questions, please feel free to ask. Victoria, if you're in there, just leave it in the chat if they have any questions, and I'll be able to get to it. All right.
Chris, I have a question.
Yes.
Is it required for us to actually have a Python compiler readily available, since currently I don't have one? I had to delete mine for memory space, so
it's all right. You don't need a Python compiler. I mean, I'm stuffing a ton of information to you in like an hour, so it's okay if you follow along.
of course.
This will be recorded, and the source code will be posted on GitHub, so you can like always reference the compiler later.
Oh, thank you. Okay.
Yeah, all of our workshops are posted on YouTube and such. Okay, you guys ready for information overhaul?
Yep.
Okay, I'm going to skip this part first. This is the Hyperloop control system, in which most of the members in person right now are actually from Hyperloop, so they need to know this, but not now. We're going to go ahead and go from the very beginning. We're going to go ahead and create a repository, use Github Desktop. Again, these are all skills we covered in the first 2 Python workshops, which were recorded last semester. So this is like a continuation of that, which is cool that we can do things like this. So I'm going to use Github Desktop. Now, remember, at any point, if you don't understand anything, just let me know, all right? So Github Desktop is a piece of software. If you ever heard of Git, that is like the premier version of version control. If you're working with another teammate, it's good to be on the same page code-wise, and Git allows you to collaborate with not just one person, but many, many people. So if you go out into the industry, a lot of people out there do use Git, like Apple, Google, Facebook, software engineering. Git is a great way to organize everything. You have people at different levels, like your junior developers, your senior developers, that will review code with each other and merge and collaborate to form one giant repository in which every single code or all the code is stored, so that you have like one central place and you have a lot of workers working on that same code. This doesn't just apply for small projects, but doesn't just apply for large projects, but small projects as well, which is why I really recommended to use it for at least this project, if not others. Like if you're in computer science, you'll use it a lot for things like making websites and such. So this is GitHub Desktop. We're going to go ahead and make a new folder or make a new repository, and I'm going to go ahead and post this afterwards. So when we create a new repository, I'm going to name this cpp-hyperloop. Yes, Addie?
Oh, if you're trying to show your screen, all we're seeing is the PowerPoint. We're not seeing
okay. Thank you. Okay, should be it. So we're going to go ahead and create a new repository called cpp-hyperloop-python4 workshop. And I'm going to name this sockets, servers, and UI through tkinter. So usually you go ahead and initialize it with a README. The README is basically a summary of all the components in your repository. Git Ignore. This just hides any files that you don't want being shown. I'm going to have a basic Python Git Ignore. And I like the MIT license because I have a lot of open source code on my GitHub. So the MIT license just protects me from, or it just says this code is open source and can be used by anyone, but it does give me some basic protections along with it. Okay, so this is the very beginning of it. I'm not going to publish the repository yet. We're going to go ahead and open this repository in Visual Studio Code. If you have any other compiler, I think Atom also works. It'll go ahead and display Atom here, but everyone uses Visual Studio Code, or most of the coders I know use this because there's a lot of extensions that really help you with coding. So we're going to go ahead and enlarge this right here. And then what I'm going to do is I'm going to create two pieces of code. So one of the first things we're going to talk about is servers and socket and multi-threading. So we covered this at the very beginning, at the end of Python 3. If you were here or if you watched the Python 3 workshop, we went over socket at the very end. I remember that I clearly didn't get it completed because some of the protocols weren't working for me, but hopefully they'll work today. So what if you're not familiar with socket is, it's how you can have one Python script on one device talk to a Python script on another device through a local network. So for example, if I had a Python script on my computer, which is monitoring a UAV or UGV or Hyperloop pod, UAV standing for unmanned aircraft vehicle, UGV unmanned ground vehicle, and any other wireless device that we need to monitor. We can have a Python script hosting on our computer and a Python script hosting on like our Hyperloop pod. These two devices are wireless, but they talk to each other through a local network. And this local network is what we're going to send data packets through. And the thing we're going to put it through is called a socket. So a socket allows for encryption, decryption of data that's being sent from one device to another. I'm not going to use a Raspberry Pi for today's example, but I am going to use two different instances of command prompts or terminals on my own computer to demonstrate this. So if I show you a command prompt, just know that this can be another device. It just has to be correctly formatted within the TCP/IP configurations in your computer. So TCP/IP is like the networking protocol we're going to use. If you're a computer engineer, it's something you might learn in an elective. But let's go ahead and start. I think I've stalled for long enough. We're going to create a client .py and a server.py. Now, these two pieces of code are kind of like the backbone of what you're going to be working with. The server usually is a central location. So think of like Central Station in New York, where it can receive a lot of clients. Like it can receive multiple client connections. So like it's like the stations, the trains coming in and out of Central Station. But there is one central server which can connect to a lot of different clients, right? And between a server and a client, they both can send and receive data. So a server can send data to a client can send data to a server, and then they can do this at the same time. The reason they can do it at the same time is because of multi-threading. And multi-threading is the process of running two functions at the same time in a script. So we're going to go over that later. But for the first part of it, at least, let's go ahead and create our server and client instance. And I am going to rush through this because we need to cover a lot. But the library or dependency you're going to use is the socket one. And I'm going to import from thread, import the asterisk, and I'm going to import the threading. And this will allow us to thread different instances in our code. So when you're coding in Python, a good way to start is to define your global variables. So I'm going to have my global variables up here. Okay. And if I do run into any global variables, I'll go ahead and put them down. But as for right now, I don't have any, so it's completely okay. And we're going to go ahead and define our starter code. So our starter code would be our name equals main. So when the Python script first runs this code, it's going to go ahead and detect this sort of script, and then anything under is going to be ran first. So it has a main function, which I'm going to define. This is basically like the start of any Python script. You have your if name, equals to main, and then you declare your main function afterwards. So I can go ahead and print hello world, like that. Something simple. And as for a refresher, when you run the Python script, it's going to skip past this main function because it's a defined function here, so it's not going to run that. It's going to skip to this declaration, and of course, name is equal to main, which is the standard definition of a Python file, and it's going to run the main function, which routes it back here, and it prints hello world. So just as an example, we can see that happen here, and we have hello world. I do think I need to enlarge this a little bit, so let me go ahead and do that. So next, we're going to instantiate our server object. Now, this is the beginnings of our connections with our client here, because we need to set everything up in the server first. So our server variables, we're going to set up our server variables. And for each server, you're going to need a host. And host is going to be our local server for now, so 127.0.0.1. And then we're going to have our ports. And port, we can just choose any number between 1 and I think it's like 10,000 something. But as for right now, I'm just going to use any random 4-digit number. I like to use either 1234 or 8009 in this case. I'm going to set my buffer size to 8162 so that I don't get too much data passing through. I'm going to have a timeout of 10 seconds and a sensor count of 1. Okay. What I'm going to be making here is what's called a loopback server. So a server, a good one at least, will go ahead and listen for connections, and it would connect to a client if a client is available. If there's no client, then it's just going to wait for another client. I don't want my server to be running at all times, right? If you ever played Minecraft, it's really tragic when a Minecraft server goes down because no one can connect to it, right? You will really want a server that can be running 24/7 for a lot of productivity to happen. So if you take the Minecraft server one for an example, I know CPP Robotics has a Minecraft server. Their server is running 24/7, and anyone can connect to it and play on the Minecraft server. So if you go ahead and play on the CPP Robotics Minecraft server, what you do is basically you're a client connecting to a server. And when you're playing on that Minecraft server, you are the client. And you have other players too, like multiplayer is a thing. So there's a lot of different clients available. So we don't want the server to close after one connection is made. So we're going to initially bind to port. We're going to set the server up onto the cloud, basically, or whatever your local network you're using, so that it's available for clients to connect. And I'm going to use my variable s to do so. I like to use a simple variable like s in order to represent a server, because the more complicated you go, the less you remember it. And for servers, you reference them a lot. So I'm going to set s equals to socket. Okay, now here's the complicated part. And under the socket library, you have a different instances of settings, and you need these specific settings to complete the socket declaration. So we have socket.sockstring. If you want to know exactly what these do, you can highlight it or look at the definitions inside the socket documentation. Next, you would bind, and you want to bind to the host and port, and make sure the host and port is a tuple. So it's encased inside one argument. Next, I'm going to listen for the connections, and I'm going to listen for these amount of sensors. So sensor count will limit the number of clients to 1. So for example, in your Minecraft server, if you don't want like everyone in the world to join, you can limit this variable to like 10, and then only you and your 9 other friends can join the server and play on it. But in this case, we only listen to 1. And I'm going to also set the timeout. So set timeout to 10 seconds, because I don't want my server to keep looking for new servers for a long, long time, because they'll exceed the memory buffer and cause a segmentation faults, which is bad. They say segmentation faults can only occur in C, but they can also occur in Python if you like run out of memory to do things. So listening on, and I'm going to go ahead and do this. And I'm going to go ahead and host string ports, okay, which is just going to let us, see whatever is connecting to our servers here. Now, here's the important part. We've already set up our server. Now we have to let the server search for our clients. And this is going to occur in a while loop. It's going to keep searching for this data for a long, long time. So what we're going to do is we're going to set up a while loop. So I'm going to do while true. And then under while true, I'm going to make a try catch. And the reason I do a try catch here is because sometimes your server will time out. And if it timeouts, it causes it to throw in an error. And sometimes we don't want that error to be thrown because we still want the server to run. So instead of fixing that, we just put it in a try catch so that when the error happens, it just keeps on running the code. Well, it tells us there's no server, but it'll keep on running the code. So it doesn't stop the script entirely. It's kind of like when your Minecraft server crashes and, because of too many blocks, and then someone has to go in and manually restart it. Or you can have a script manually restart this, automatically restart the server for you. So we have server activation. And I like to use the variables con, addr, which stands for the connection and address for the server. So what this line says is that if the server sees a client, it's going to accept the connection, right? I'm not doing any fancy encryption stuff or like checking to make sure that the client is safe. It's just going to accept anything. So this is where you got to kind of be careful when you're designing some network architecture, because if you want to be safe, make sure you encrypt your channels and everything. Otherwise, you're going to be left with some fun security problems. But I'm not going to discuss security problems here. Okay, so what I'm doing now is I'm going to instantiate my threads. So remember, we talked about multi-threading previously. So when this accepts the server, it's going to do two things. It's going to create a thread to send the data and a thread to receive the data. Each server instance, server-client relationship is going to have these two threads, because you cannot send and receive on like the same thread. You got to do it separately, because you can do it at the same time almost. You're not going to run into any funny timing issues there. So to be safe, multi-threader functions. You learned in basic coding classes that functions basically run top to down. There's only one stream of information. Well, you can have two streams running at the same time if you multi-thread. So it's double the productivity, but the same code. So I'm going to go ahead and make two threads. One is going to send data to client. And I'm going to have thread it again. I'm going to receive data from clients. Okay. And here in the thread, I'm going to have thread underscore send equals threading thread. Here we're using the thread library in order to create our threads here. So my target is going to be some function I'm going to I'll name it like serve proc. So I'm going to proc serve. And I'm going to pass in my variables con args equals con addr. Okay. And then I'm going to go ahead and start this. So thread underscore send dot start. And this is basically going to start the thread on a separate process in my computer. Now, threading is really important to know, especially if your device is capable of doing it. Your device needs to have enough RAM, first of all, to be able to do threading. So devices like microcontrollers, so like Arduinos, those cannot be threaded. Raspberry Pis can be threaded because it has enough processing power to do so. You need enough processing power to run things in parallel, which is why most computers are capable of doing this, and which is why most languages like Python run on high-level devices. Right? You don't need to manage your memory on anything. You don't see people writing C a lot for high-level devices at least. They usually do it on like controllers and stuff. If you're taking 3301, you know what I'm talking about, assembly and stuff, a lot of fun. Screaming at me for an error because it doesn't know what this is. So let me go ahead and declare our functions first. Now I'm going to delete this global variables because I don't think there's any global variables in this code, but there are separate functions. So I'm going to make a function called serve proc. This is the function that's serve proc. And this is the function that's going to send our data to clients. What data are we going to send, you may ask? Well, sending any data we want, theoretically, which is cool because if you have something like a race car that you want to control, you don't have to control it with like a RF controller. You can also control it with a computer. You can have the car send data back to you like it's sensor data, so like your accelerometer data, your temperature data, your pressure data, whatnot. All these kinds of data are going to be do exist in Hyperloop. That's why we teach this in the first place, because a lot of the sensor data and feedback control systems originate from this script right here. So serve proc, I'm going to go ahead and pass in my connection and address variables. So my con and my address variables, ADDR. And inside this, I'm just going to print something. So print server control function activated. This is so that when we run the code, we can specifically see what's going on and if this thread actually is ran. Threads do not run if there's no synchronous procedures within it, which means that if you're not timing it, or if there's no function that requires time, it's not going to be able to create this thread successfully. Our time function here is located inside our server declaration because it's continuously finding or trying to find that server, unlike a non-blocking timeout, So I'm going to go ahead and start this. It should not yell. Oh, I have one more extra parenthesis. Let's see. So I'm going to go ahead and create my next variable, or next thread at least. I'm going to have thread underscore recv equals threading thread with my target equals to, let me call this data receive underscore client. Right. These can be any name you want. On ADDR, and this thread is going to be the one that actually receives the things. So threads underscore receive start. And of course, I'm going to have to create this new function up here. Def data recv underscore clients. Now, of course, you're going to probably want to name these something that you may understand, like the function of the function, like the purpose of the function, like why are you creating this in the first place? And I'm going to say like pretty much the same thing. So like let's say client data retrieval thread activated. Okay, so basically I have my two threads which are going to be running in parallel with my main script. Theoretically, there's actually three threads if I run this code right now. One is the main thread. So one process is going to look over the code or it's going to be located on the server and it's going to look for clients. This is my observer process. So it's going to keep looping. It's going to try to find a server, or it's going to try to find a client, and it's going to try to connect to it. Once it connects to it, it goes ahead and makes these two other threads, which is one's going to send the data and one's going to receive the data from that specific client. And it's going to keep searching for clients. Now, if we increase the sensor count variable here to like 2 or 3, we can basically have more and more threads available. But currently, it's not able to connect to more than one device here. So I'm going to go ahead and complete this while loop. So one of the processes is almost completed. What I have left to do is complete this exception. So if our server is not able to find any new clients in 10 seconds, it's going to error out. It's going to say, hey, I don't have any new clients to connect to. Let me go ahead and try to crash your code, basically. So to prevent that, we're going to have an except right here, and we're going to say print no server. Okay. Another one we're going to have is except keyboard interrupt. Now, this is very important because if you want to close down a server, it's a little bit difficult. And let me show you why. Because you got to make sure you kill all the processes pretty carefully, right? And these processes are called children of the main function, of the main observer function. And you can tell, like, usually when you're Googling for bugs and you want to know how to kill a process, and a process called a children, really easily get on an FBI list if you're not careful enough. So not to say that I haven't done that before. But so a lot of things in programming and electronics do have some humor in them. Like I discussed in the previous soldering workshop, how some jumper cables are called male and female jumper cables because of their shape. A lot of fun. So we're going to go ahead and put these two except statements here just to catch errors. Specifically, if you want to exit a code, you want to press Control-C, it's going to boot you out of the code. And if you don't have a server, it's going to say no server. And we're done with one process. There's 2 more to go, right? In order to define this server entirely. Before I move on, does anyone have any questions?
Chris, I have a question in regards to some of the, what is it called, variables that you use. So those came from the server and the socket libraries, correct?
Specifically, which ones?
Like threading, point thread, keyboard interrupt, those kind of things. Because I understand like you can easily define your variables in Java, but like some of those like functions, and if I'm referring to those correctly, it's just that like yeah, it seems like it just came out of nowhere, or like it seems like you need some kind of library to do so. Am I correct in this case, or?
Yes, you're exactly correct. And good question. So you caught me there because I didn't define this, but if you have a equal sign to this, that means you're defining a variable. However, if you're using some like .start method, that's going to be a function. And these are not default Python functions. Keyboard interrupt is actually a default Python function. It's built in, it catches errors. But this one is from the threading library. So if you look up here, we imported stuff from threading. This is the external library or dependency that we're going to be using for multi-threading processes. This is not contained by default in Python. You have to import it in.
I see.
Yeah. And so, so for this one, what we're doing right here actually is we are creating an object of the thread class, which encompasses the function itself. And so this thread is a class, and we're creating an object. So this thread underscore send has the data type of an object, and that's why we're able to use it to call the start method.
I see.
Good question. All right, let's move on to serve proc and data receive client. So first, we're going to deal with this function up here. Serve proc, as I defined before, we use to go ahead and take the data, and then we're going to send it to the clients, right? So this is a one-way communication. This one down here goes the other way. So we have two-way communication at the same time, which is a lot of fun, and it's really useful for a lot of applications. So yeah, once you figure out some of this stuff, you can basically reuse it for like whichever other application you do in the future, which is pretty nice. I use this in a lot of projects. Okay, so we're doing server proc first, right? All right. One of the main things you got to do when you're coding is to actually leave comments, right? I'm going to leave comments. This is my own commenting style. You guys may find some of your own commenting styles in the future. So I'm going to go ahead and, because I like to put in square brackets what this function is for. So this is a thread, which takes data and sends it to the client, right? This is also a thread. It receives data from the server, right? And this last main function is just a regular function. Main function where everything happens. Okay. So under the server proc, remember, we got to go ahead and send some data to our fun little server here. So what better way than to send a list of numbers, right? In Hyperloop, what we do is we have a lot of data that comes in from the Arduino. Again, we have the IMU, which is like 20 data points. You have temperature sensors. We have like 5 of those. We have voltage sensors. We have pressure sensors. A lot of sensor values are individualized and can be represented as a number, like an integer or some other data type in case of a overflow error that you need like a longer data type for. So based on that, we're basically importing numbers, right? So I'm going to go ahead and create a list. And basically, this list is going to have a length of 25, let's say. Arbitrary number, right? I'm encouraging you guys to go ahead and use this code or like make some variation of it for your own applications. Like you can use this for robotics. You can use this for some kind of space mission. You can use this for underwater diving, autonomous drones, you name it. Yeah, these are the fundamentals for taking on bigger projects like that. So in this case, I'm going to go ahead and set up my while true loop. See, the thing about these functions is that once you complete the function, the thread is closed, right? you don't want that to happen because you want to continuously be sending out data and receiving in data, which is why we have these while true functions here. So I'm going to say if con, and I'm going to pass it. Now the pass keyword is really useful for this code because it allows you to put in a placeholder for your code that you're going to write in the future. And this is really useful because a lot of times I have like gigantic scripts of Python code that I don't know what's going on. And I have a lot of top layer ideas. So like I have a lot of function ideas and I want to boil down to more specific ideas. So that's how I do this. I use the pass keyword to leave a space there so that the compiler doesn't yell at me. And this is important because remember that Python does not have semicolons. So if you don't have semicolons, how does Python know how to place things? By indentation. So you have tabs, you have spaces. I actually use tabs, or I use spaces here. 4 spaces equals 1 tab. And if I use the pass, it knows to just leave a space there for me to write code later. So what this code does is it checks that the connection is available, which our con variable. I don't think I explained this. So when you accept, it's going to give you a tuple, and it's going to assign these ones to the specific elements inside the tuple. Connection, or con, stores all the server data, like your IP address, what's connecting to it, like your IPv4, IPv6, whatever. All that data is stored there. And ADDR is just storing your address, like your local address or your public IP if you're connecting over some sort of public interface. That's ADDR. So in that case, we're not gonna use ADDR. You can use it like in your print statement. You can say server control function activated in, let's say, use the F string, and then you have ADDR here. And this just controls the address of the server that you're looking for. So this checks if the connection is available. If the connection is not available, then it's going to exit the thread nicely, of course. And this connection specifies your client, by the way, so what you're connecting to. So if con, I'm going to go ahead and describe my list here. Data equals 0, and I'm going to multiply this by data length. This will create us a list of all zeros in one single line. Very simple. I'm also going to create a string, and I'm going to send the string across my socket, and the string is going to be empty. Okay. Now I'm going to create a for loop for I in range, and this is a for loop in Python. It's much more simplistic than your regular old for loop. And I'm going to set it linked to data. So it's going to iterate through each element in my list. So for each element that it iterates through my list, I'm going to go ahead and say that data I, so each element inside my list, is going to equal to a random number. And I don't really care what this is right now, because I'm just going to do a theory. But we need some numbers to stuff into our client so I can demonstrate some of the UI interfaces that we're going to be looking at. And random is going to be something that we have to import too, because it's not a default library or default class in Python. So if we go ahead and import that, random is going to be lit up, and we're going to see that this has already been specified as the random function, or sorry, the random class. So this is going to put a number between 0 and 100, a random number into data I, right? So for each element inside the list, it's now going to contain a random number. And I'm also going to go ahead and add this to my send variable. So send plus equals, I'm going to turn my data into a string so that it can be concatenated with a space. This space is very important because Python actually has a fun function called .split, which can take a string and break it back into a list for you. And this is the trick we're going to use to quickly send this data over to the server without using some more complex stuff like a JSON load and a JSON dump, which is basically how you send whole dictionaries through a socket. So I'm going to go ahead and send this. Now, I'm going to use the client's address or the client's information. And I'm going to do .send, which is the method contained inside the socket library, or the object of the object of con, which is the client. I'm going to send my data, which is sent, right? That's the string containing all of our little individual elements. Now send can't just be sent like this, because it's really, 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 really hard to send a string through a socket. String is way too large. So what we need to do is we need to encode it in something that's more processable for the compiler to send. And so we're going to do this using UTF-8. Whoop, whoop, whoop. Now, the most simple way I can describe UTF-8 is it's a bunch of gibberish that you can't understand, but the computer can. And it means the exact same thing as your text. UTF-8 is also easier to encrypt than just regular words. So we usually do this. Now, you're not going to see the step, but just know that when I run this code, the compiler is going to take all my numbers inside my send variable. It's going to turn it into UTF-8. It's going to encode it into this long list of symbols that we don't understand, but the computer can understand. And it's going to send it through its socket. And this is going to be very, very fast. After we do this, we are done, right? Our server proc function is complete. We have successfully sent a packet of data, which is in this case, it's just numbers. In Hyperloop's case, we would have data from sensors and whatnot, but we'll get into that later. Next, we need to code up the received function, in which it receives all the data from the client. Our example today is we're going to create a tkinter interface in which we can use our keyboard to control a theoretical robotic car. Now, I hate using the word theoretical, but just for example here, I'll be able to press buttons on my keyboard, and we're going to see it appear on the server. And our server is going to be our computer, and our server is going to process all the things. And then, maybe if you connect it to an Arduino, it'll be able to control the Arduino in that method. So our data receive has to receive the data from the client. Now, receiving data is a little bit more tricky than sending out data. And let me just explain this right now. So I'm going to go ahead and set my while true loop to first, because we need to make sure that our instance of a server continuously receives the data over and over again, right? We don't want it just to die in the middle of a process. So we do the same thing. I'm going to make I spoiled you guys, so I'm not going to do that yet. I'm going to set a variable called message, MSG. I'm going to make this a receiving. It's going to receive the data from the client. So I'm going to do con.recv, right? This is the basic function that I'm going to receive from the client. This works, but in case, right, just in case, what we're receiving is too big of a packet. Sometimes packets build up and they overflow into one another, and then we get some ridiculously big packet that we're not expecting. We want to limit the size of this just to make sure that everything is in order and we don't get any interrupts. Like lining up at the airport. You want to make sure that everyone is in a single file line and not just scrambling to get their tickets. So in this case, I'm going to limit it to 16 bytes of data, which means 16 characters. Each character can be represented in 8 bytes using ASCII code, which goes from 0 to 255 and represents all the letters in the English alphabet, including the capital letters and all symbols. So 16 bytes of data. And then I'm going to go ahead and .decode UTF-8, because you have to remember, all the data that goes along these servers that's being passed into the clouds is data that we can't understand. If we take a look at this, if any human just goes ahead and looks directly at it, they're going to see a bunch of symbols. It may represent confidential government information or some other important information, but just a regular onlooker wouldn't know what to expect, right? Because this is just gibberish for us unless we decode it. So using this function, decode is a built-in Python function, by the way. We can go ahead and turn this gibberish back into something we can understand. Now, here's the tricky part about receiving data. Sometimes you're going to get nothing, right? It's just going to give you no data at all. We got to be careful of this. So in order to find out if the client's going to give us no data or some data, we go ahead and make an if statement, a conditional, in which we're going to say if not message. If not message, which means if there's nothing there, if there's no message, if the message is empty, right? If nothing got sent over our interstellar highway, we pass. Otherwise, if there is something, we're going to go ahead and print our message, right? So this will work fine. There is an exception though, which you can protect your all your functions or questionable code that you have in the future with this simple trick: try catch block. So we need to make sure that our program doesn't crash, because there is a chance that it might crash in the middle of this function, right? So in that case, we will go ahead and do except exception as, and we're going to go ahead and print our error message. Error. E could not send data, or this is could not receive data. Terminating thread. Okay. Now it's important that we catch our errors with exception as E, right? Because sometimes your error might not be known, and E is just a variable that stores like a string of the error message. Your code is going to continue running even if the server dies, or even if the client dies. So think of it like the Minecraft analogy. You're playing on a Minecraft server with your friends, right? If you exit the game, and remember, you're the client, right? If you exit the game, you don't want the whole server to crash, right? It's the exact same thing here. If a client leaves, right, this is going to go ahead and break. It's going to close this connection nicely using the con.close method, and it's going to break, right? So this thread is going to close, but our main processor function will still be here. This is going to still be running in a loop, right? So again, we don't want our server to crash when a client leaves. We want to still keep going. So that's why we use this exception right here. Our try catch block will allow us to catch the exceptions, but won't kill our code. So this is done. We're done here. This is the entire server code. We're going to move on to client now. So our server is set up, which means that if we run this server right now, it's going to go ahead and start looking for clients. And we can actually do this, and it's really cool. And here's how we do it. A fun part of using Github Desktop, or just like any Windows computer in general, is that you can go to repository and you can show this repository in your Explorer. What this does is it goes to the direct absolute path inside your computer in where your files are located. So inside this is CPP Hyperloop Python 4 workshop, right? And in here, I have my server code, and I want to run this server code in my Python directory. So I can go ahead and click this up here, and I can replace this with CMD. Now, when I do that, what happens is that my command prompt opens up, and it directs me to the exact directory in which my code is stored. So if I go ahead and run Python 3, right, this by itself will check for me which version of Python we're on. And I'm on Python 3.9.12. Any version of Python 3 is fine. So I'm going to go ahead and exit this. Okay, just kidding. Doesn't let me do that. Forgot I wasn't in Linux. In Linux, clear will just like clear all the commands. But in this case, let's go ahead and run our Python script. So Python 3, and then we're going to put server.py afterwards. This is how you run a Python script in your command prompt, by the way. I'm going to press enter, and it's going to start listening. It's going to listen on 127.0.0.1:8009. Now, the specific address, remember, is our IP address, colon, and then our ports. This is a very important TCP IP networking question. Gets asked on interviews sometimes. I think there might be even some like test questions on it if you take the elective. I've heard from friends that this is a big topic. You know, even if this is how you sign on to Minecraft servers too, you know, might do a Minecraft server hosting tutorial later on using a virtual private server. I have yet to do some fun workshops. I also have a Discord bot one lined up. But as of right now, we're just here. We can see that it says no server because it can't find a server. Actually, this should say no client. I should change that to no client, because if it doesn't find a client, it should say no client trying again. Right? Even with your comments, you want to be as specific as possible, but inside your debug statements, like these print statements right here, you want to be as specific as possible as well. So let me go ahead and Control-C. Now you gotta wait a little moment for it to wrap back around because the timeout sometimes acts as a blocking function, but it should eventually go ahead and get ourselves out of here. So keyboard interrupt, got us out, and we're back here. Now we can run this again. And again, it listens on our IP. Remember that our listening on IP debug statement is located on line 52. We print listening on and our %s%s, which is our formatting, and it's going to show us our host and then our port. Now, if our client is not listening on this port, or it's not trying to bind itself to this port, it's not going to connect, right? It has to be this port. And now you see it says more accurately, there's no client, and it's going to try again. Okay, I'm just going to leave this to be, drag it to another screen. We're going to come back to that later. We're going to code our client.py. Now, if you thought the server.py was long, the client.py is even longer. So buckle your seatbelts. We're down for an adventure. We're going to need a lot more functions in this case because we're going to be diving into TK. This is the second part of today's mini lecture here, which is how you can actually create a user interface or UI in Python using the tkinter library. So we're going to go ahead and import some essential dependencies. So import sys, import socket, import tkinter. And I like to import tkinter as tk because it's just like faster to code. And you know it's like only like 4 letters less, but you know it's still faster. And I'm going to import math. And I'm going to import pil. Okay. And I'm going to import my threading things. So, oh, actually, this is going to be from. So PIL is a big little dependency here, and it has a little bit of smaller dependencies underneath it called image and image TK. That's where that comes from. And I'm going to do from_thread import asterisk. I'm going to import everything. Whenever you see the asterisk symbol, it's going to import everything into it, right? And I'm going to import threading. Okay, we're going to need all of these just so we can host the user interface on our computer and then connect to our server, which is going to provide us the data, right? So first of all, before I do anything else, I'm going to go ahead and instantiate some sort of security measure. So whenever you do this, especially if you're going to upload this to GitHub, and specifically if you're uploading it as a public repository, make sure that you don't expose any IP addresses, especially clients. Because as a back-end developer, I'm going to assume that multiple people are going to be using my code, which means that the host isn't going to be just one host. There's going to be like multiple different IP addresses. And I'm not going to hard code it in like some normal person. So what I'm going to do is I'm going to allow the user to type in their IP address when they're running the code. So you remember how we did, like we did Python 3 server.py? We can also type in our IP address in the command prompt as an argument into our code. So in here, we're going to do length sys.argv. And then if this is not equal to 2, we're going to go ahead and print a usage statement. So we're going to say usage Python, I can't spell, Python clients, Python 3, clients.py. And then I'm going to notify them that they must use the host IP. Okay. And then I'm going to do sys.exit1. Sys is like short for system. It has a lot of system commands that you can use outside of a script, so that you can control things on your computer and things like that. As you can see from the description, it says this module provides access to some objects used or maintained by the interpreter and to functions that interact strongly with the interpreter. Right, so shorthand, you can control things in command. It's pretty cool. So you can shut off the entire script if you want to. Okay, now I'm going to say my server IP is equal to sys.argv1. Sys.argv is a list, right? Whenever you type in something to the command prompt, so for example here, this will put all the arguments into a list for you. So it's going to go ahead and take everything after Python 3 and then put them into a list. So this is server.py is going to be list item 0. And then if we put an IP after that, that's going to be list item 1. So in that case, we're going to have the server IP equals to sys.argv1, which in this case is going to be our argument for our IP address. So in that case, after this, we're going to go ahead and instantiate our server variable as, or sorry, our client variable as a S. This is actually a socket object. So I'm going to do the exact same thing. So socket.socket, socket.af underscore inet, comma socket.sock underscore stream. Okay. Now, this is the client. So you remember inside our server code in which when we set this up, we have to bind, we have to listen, we have to set timeout, we have to do all these like crazy setup things. In the client, we don't have to. The client's main job is to connect to the server. Therefore, all we need to do is just do s.connect, and then we need to do the server IP, and then 8009. This port has to be the exact same as our server that's running on, remember? So that I can connect to each other. Now, this line is kind of like what your computer runs when you connect to a Minecraft server, or any server in general. Like you connect to a website, something like this gets run to connect your local network to the website's network. So this is very powerful. And again, connect is a function that is specific to the socket library. Okay. Now we get into the fun part, which is tkinter. How do we make a UI in Python? Now, notice how I did not make a main function here, just for like simplicity. If you want to make a main function, you can do that later. Just do a little wraparound logic. You can also thread the tkinter function. You can put the tkinter inside a thread, but just be careful of timing, because tkinter has a different way of timing than the socket does. So if you mix the two timings together, sometimes they won't match. Sometimes they slide in very nicely, but sometimes they just like don't want to go together. And that's how you get like timing errors and crashes and bugs and all sorts of fun stuff. So in order for us to start making a tkinter window, what we do is we start by doing something like this. We make an initialization section where we create program window. So specific to tkinter, the program window is called root, R-O-O-T, right? We normalize this as root. It's kind of like a standard. So our root is going to be our main window, which is tk.tk. I'm going to be using a lot of functions, but just trust me on this. And I'll show you along the way that this works. As for right now, I'm going to go ahead and disable the code I just wrote up here, because I'm going to show you how you can basically test your code to make sure that your UI is right before managing and connecting it with the server. Okay. So I'm going to comment this out just so I can run the code, because I don't want it to connect to the server right now. Okay. I'm going to go ahead and use the function root.resizable. And I'm going to say you cannot resize this. You cannot resize this window both in the X and Y direction. So it's one specific size. And then I'm going to go ahead and create my main canvas. So what I just did here, keep in mind that everything you do in more advanced Python topics will require libraries and dependencies. This root variable is an object of the TK library, right, or TK class. Because it's an object, this object can contain methods. If you learn object-oriented programming, you know that each object has specific methods and functions that you can call that do special things. So specific to this, there's a root.resizable, and resizable just says you can't resize the window. Now, there's going to be a lot more of these, so just bear with me here. TK is a very object-oriented programming heavy topic. So here we have main canvas, and this main canvas is going to be another variable, but it's going to be an object of the TK library, and it's going to be the object of the TK canvas library, to be specific. Canvas will allow us to place a small little section on our root in order to put other elements on, like buttons. We can put labels, we can put pictures, we can put animations, we can put GIFs, however you want to call it. It's all up to you. But that's where your creativity begins and my lecture ends. So that's on for later. But to create a canvas, what we need to do is we need to state the section that's going to be on, or the window that's going to be on, which is root. And then we need to set height. We need to set width. We need to set the background color. we need to set the highlight thickness. Okay, here is where a lot of global variables come into a big importance, in which we need global variables for tkinter, because we're going to be using height, we're going to be using width, we're going to be using background color, a whole crap ton, right? So in this case, what we're going to do is we're going to make another section called tkinter default variables. And this is just my method of sectioning all the variables out. It looks really messy, but it's just like one big block of code. So I like to use a comment. I use all caps for like very important things and like just like regular words for descriptions, but tkinter default variables is very important. I'm gonna just copy and paste these default variables from the code I have on the side. Again, this will be published onto GitHub once I finish with everything, and you guys can go ahead and reference that later and run it yourself. Make sure you have all the libraries though. You might have to pip install pill, or this is actually pillow. So when you go ahead and run this code, you're going to need to go ahead and do a little pip install pillow, and that'll go ahead and install the correct dependency so you can use it. You might also have to install tkinter. I'm not sure, but you know, same thing. So pip install tkinter. Okay, it's going to be a lot of copy and paste because this is going to be a lot to write down. But in this case, these are all the global variables that we're going to be using. I can go ahead and set this height variable to height. I'm going to set the width variable to width, the background color to black. We might need to use another black background color later, so that's why we have black here. So highlight thickness equals, let's say, just 0. It's just like the border, how highlight you want it. The very important thing about the all caps letters is that they are constants. Height, width, refresh rate, offset, value offset, unit offset, label begin X, label begin Y. These are all constant variables. That means I'm not going to change them later in the code. And you know, VSC highlights them in special darker blue for you, which is, I think, that's very nice. Let me go ahead and describe what each of these do, though. So height, you're going to make a window that has a height of 1080 pixels. Width, you're going to have a window with 480 pixels. Refresh rate, you're going to have, oh, this is for our recursive function. So in TK, again, I stress that timing is very important. Timing is such a hard thing to deal with. In TK specifically, timing works through a recursive function that runs at this delay inside the refresh rate here. So 50 milliseconds of delay between each loop. And you have to define a specific function that does this loop for you. So it loops every 50 milliseconds and it updates the data, right? And everything else is static. Everything outside this function is static. So like your buttons, your keyboard presses, your whatnot, they don't go in timing variables. They get instantiated and they get threaded into a background process. tkinter uses threading too, you know, very cool. Offset variable, you have an offset variable for, you know, whatever you need. All of the offset variables just to like offset it from like borders. And then label begin X, label begin Y, just like how you want to position your labels inside the middle of the screen. There's a vast variety of functions you can use in tkinter, but this is just some of them. I'm also going to go ahead and declare my global variables. So I'm going to say this is global current key. And I'm going to set current key to just nothing. Now, as I said before, our goal here is to be able to send something back to our server and have the server respond by, you know, driving an Arduino car or something cool like that, you know? So this current key variable is going to be used in our keyboard detection code inside our tkinter script in order to send our data back to the server. So it's going to be very interesting. So I'm going to go ahead and make our canvas first so that at least we can see what's going on the screen before we add the server code, because it's really good to know what your UI looks like before you actually go ahead and write other things that might, you know, destroy it or make it harder to run. Because once you add the server, you're going to have to start the server and then run this script, and it's going to be like a battle of two scripts. So you just want to go ahead and press the play button up here in the top right corner and run the code. Makes it a lot easier. So I'm going to go ahead and create the canvas. And inside here, this canvas is going to be an instance of the main can. So I'm going to go ahead and copy paste this code here. Again, I'm going to write this down. So this control canvas code is going to be an instance of main can. So it's going to place this smaller canvas on the larger canvas. So you see how we can nest different canvases here? So if you want to place things specifically, like you say you want a UI for like a map, and then UI for your statistics, and then UI for your controller, you can all place this in the same window by having multiple controllers. In this case, we have a controller which has a width of 360, a height of 900, and then the same background colors and highlight thicknesses as before. You notice that the width and the height are lower than the ones described for the main canvas, which means this is a smaller canvas on the larger canvas. Pretty interesting. Now, next, we're going to create something very fun. And this is going to be our class. This class is basically how we're going to simplify putting down labels. And labels for, for our data, like accelerometer data, IMU data, sensor data, whatnot. This uses a lot of TK label, which is a label object, but it simplifies things for us because look at what we're passing in. This is a class. So in object-oriented programming, you have classes, right? And this init is a constructor. So when you are creating a label, this will take whatever you had and simplify it down to the following things. You're going to pass in yourself. Actually, you don't even pass this in. This is just of the class itself. You're going to pass in your master, which is root, a string as to what data you want. So this is going to be like acceleration, for example. Your value, your acceleration of value, your units, which is going to be meters per second squared, for example, your list position, and your offset position. Basically, what this means is that we can have a list of labels and then start placing them in like one by one, like in a vertical line. And it's just going to have the system of basically saying what it is, what's its value, and what's its unit. Because we're analyzing things like battery voltage, battery current, sensor data, it's really useful for us to have this sort of structure here. Now, the next two are going to be our actual label definitions, right? Can't have it too easy yet. This is going to be a lot. tkinter, usually, if you want to design your own UI, it's a lot of guessing and checking. But luckily enough for this purpose of the workshop here, I know I'm already over time, but we have already coded this for you. So basically, what happens here is, yes. We have two different kinds of labels. One label will go ahead and create our title for us. So this is going to be CPP Hyperloop, Python for Workshop, and then click on the GUI and then the instructions, right? Each label from the label class has a location as to where it's being placed. That's the main camp. So where it's being placed has the text itself, has the font. Now the font you can define by a tuple. You'd say the font name, its size, and its qualities. So I want this font to be Courier New, like the robot text. I want to have 24-point font, and I want to bold italic. Justify, I want to put it in the center. I want to have the background as black, and then my foreground as my color of choice. Now this is a hex color, and if you go to like hex color picker or like go to any online website that has this hex color here, it'll give you the exact color. And this is the color of our logo, by the way. Underneath, I'm going to place the title. Again, remember how we had this kind of structure for threads? This time it's going to be for title and title.place. Now title.place is going to, because our title is already a label object, we're going to place this relative to the X, relative to the Y. This is going to be 50% like between the borders of the X. So we don't need to do any calculations. So 50%, which is in the middle of the page, and then rel Y is 0.075. Relative to the exact height, it's going to be like near the top. So this will allow us to parameterize these positioning so that if we do want to change our canvas size, it wouldn't be too difficult to do so. And then we want to anchor this to the center. Pretty simple stuff. We repeat for subtitle, we repeat for instructions, and it's pretty much all the same structure. So as long as you know what you're passing into the label object, this whole deal is really simple for you, right? So this label object here, again, I'll repeat this one more time, has where you're going to place it, what text you want to place in it, the font and its details, where you want to place it, justify left, right, or center, what the color of the background is, and what the color of the foreground is. What the color of the foreground is like the color of the text, basically. So we're going to get into TK label unit, which is our custom function. This function is not a function of the TK class. We created this just so we can get our data values easier. So in this case, in our class TK label unit, we actually place 3 different labels here, right? Notice that instead of 1 label, we place 3. And because each 3 of these is going to be for the name of like what we're going to be putting, so like temperature data, like in Celsius, our values like 32 degrees Celsius, and our unit Celsius, right? And based on our offset, it's going to place them next to each other, right? Given a good enough offset. And I'll show you what I mean. Everything down here abides by the same rule, right? We have system, gyrometer, accelerometer, magnometer, and then this is just like an empty space, right? I'm going to have a spacing. Notice how basically all of these are inside a list or inside a data structure that is defined by the TK label unit class, right? So it's going to pack all of these in a vertical structure all the way down the window. So it goes from 0 and then it goes all the way down to 24. And this just says all the data that we have. For example, our IMU data, our board temperature data, our voltage current capacity. There's even more in the Hyperloop. This is just like a simplified version. So you will notice that the value actually says error instead of an actual value. Our job is we need to take the data that we imported from the server and drag it into the client so that we can replace this error with an actual value. We're not there yet. So let's go ahead and run this code. We cannot run this code yet because we have not actually created the window. So let me go ahead and go through one last thing before we go ahead and press play. So in order to create this window and keep looping on it, so keep generating the same things, keep pulling the same buttons, we need to go ahead and write this code, which is to update and refresh the window. Okay, so this is to start calling the update function. Oh, actually, this is not yet. Not yet. I went too far ahead. So we need to go ahead and type root.mainLoop first. This will go ahead and start the window for us. Just one line. And this calls the main loop and actually starts all the processes I was talking about in the internal TK library. Okay. You guys see the window? Doesn't look too hot, does it? Nothing's there yet. So now we have to see why nothing's there. Main cap. Main cap. I did not place the main cap yet, did I? I did not place the main canvas yet. Okay. So in order to place things, right, everything is linked to the main canvas. You have your control canvas, and then you have everything inside the control canvas, and it's all pointing to each other, and it's pointing to references that lead up to main canvas. So in order for us to actually see the window, we actually have to use the command .pack. This will place it inside the root window. So I'm going to go ahead and also run main_conf.focus _set. And now if I run it, beautiful. There it is. So this is our user interface that we've created, just based off of what we just described below. And you'll notice that the instructions here is to say, click on the GUI, then use the WASD keys to remotely control the robot. Sensor data from the robot can be seen below. This was an actual text from a project I yoinked from. I love reusing code. But you can see how everything is aligned to the center, and we all have error values because we haven't passed any data values in. And in order to begin passing in data values, we need to create an update function. So let's go ahead and code in the rest of the pieces of the puzzle, which we need two more things. One for the button logic to send things back to the server, and the second one being the things to receive from the server. So again, remember that TK has different logic, different timing logic than our socket. So if we combine them, we don't want jams to occur. We want to slowly and successfully slide them together so that they work in tandem. That's the difficult part. So let's go ahead and exit out the window. We know that the window is nice and neat and carefully made. So now we need to code in our last two aspects of the puzzle. And first, we're going to deal with the data. So we're going to go ahead and assign a really important function called the update function. Okay, so the update function will recursively loop to update the data every 50 milliseconds. Okay, and I'm going to set this as a function, which is update data. Okay, inside the update data function, and this is where I'm going to start uncommenting out my server logic, because I'm going to deal with the server now, right? I need to retrieve data from the server to put in my client, and I need to push data from the client to the server. Okay. So first of all, I'm going to need to know what I'm getting from my server. And in this case, I'm going to get a long string of numbers. Remember that? So I'm going to get a message. And my message is going to be s.recv. Remember that? We're going to receive the data from the server. And we're going to receive this message of length 4,096 bytes. Now, I know this may sound like a lot, but this is just about like 4 megabytes of data. Sorry, 4 kilobytes of data. It's not actually that much. So this is just in case we need to like send more data over. You can get more exact if you want to like save like speed, processing speed. Like the more exact you get, the faster your code will run. And you want to decode this, .decode, using UTF-8, right? Because UTF-8 is how we unscramble the scrambled data. When we tossed the data over from the server inside server proc, right? Remember, we had to go ahead and send the data by encoding it in UTF-8. We have to scramble the data so that it'll be faster to pass to the socket. And then when we receive this data, we have to decode it back again so that we know it's back in a string that we can understand. Next line is to give us a list called nums, and nums will be message.split. Now, remember that message is a string full of 25 numbers, each separated by a space. Split will go ahead and turn that string back into a list, and it will use space to separate those numbers. Cool, huh? So we're going to go ahead and now after we have our list of numbers, we're going to go ahead and assign them. Now I'm copying this because I don't want to type all this down. But based on all our individual values, like our IMU system values, it's going to change .value and then its parameter text, because the value is actually a list of different text values. And it's going to assign nums as 0 to it. So here's where we need a lot of good documentation, because you need to know exactly which type of data is in what part of the list. You can do this for like every single one of them. You see with some little fun mathematical stuff going on here and some capacity values. But this is just all representing data that we can get from our list. Our list is a string, remember that. So some of these actually have to be converted to floats. Excuse me. All we're doing here is assigning our values to our list. And now, next part is basically making it into a recursive loop. So this will go ahead and loop recursively. So root.after it's going to go ahead and loop at our refresh rate, and then it's going to call itself again. So if you notice inside this description here, it will call a function once after a given time, right? That's what root.after does. And if it calls itself, right, it's going to call itself and it's going to start running this again. It's going to assign all the numbers, assign all the data, because our data does update, right, every 50 milliseconds. And then it'll call itself again. And it'll call itself again. And it's just going to keep doing this, which is great for us because we need updating data inside of our Hyperloop pod. Now, we need to call this function for the first time. So we're going to go ahead and do what I did earlier and call the function root.after outside of the actual function instantiation. So this is like in the very left part of our code. And that's pretty much it. For receiving the data from our server into our client, we have all of these individual sensor data values that we can actually process. We can calculate numbers with it. This actually calculates the magnitude of whatever gets passed in. This actually calculates the capacity, right? It takes whatever we have, divides it by like 9, which is our max capacity, and then times 100, and then makes it into like a two digits after the decimal point. So it's really cool. We can process these numbers and everything. And we can also display them inside our UI. Now we can't actually display them inside our UI yet because we don't have a server. So before I go ahead and combine everything together again, let me go ahead and program in the last thing, which is our button logic. So a part of this lecture is for bi-communication, two-way communication. Server sends stuff to the client, client sends stuff to the server, right? We do this using buttons. tkinter is amazing because we can use keyboard buttons, like the ones that are keys, to actually control other things. Like you control text, you can control pictures, you can display pictures, you can hide them, you can whatever. If you go into OpenCV, that'll be a lot of fun. But specifically for tkinter, what you can do, the tkinter and socket fusion, you can go ahead and send stuff to a socket. And that's what we're going to be covering next. All right. So back when we instantiated a global variable called current key, I was actually preparing us to go ahead and do some keyboard functions. So I'm going to place the keyboard functions actually like under here. Okay. We're going to have 3 keyboard functions. So when you press something on your keyboard, right, what happens? We have key, you can do key up, say S, def key down. So when you press a button on your keyboard, that's key down, right? And if you release a button, that's key up. So I'm going to go ahead and pass in a variable k here. I'm going to explain what this is later. So for key up, we need to know what key is being pressed. And if you saw in the tkinter window, we actually specified we have WASD keys, right? Search standing for W is going up, A is going to the left, D is going to the right, S is going down. We need to make sure that those are the only keys that actually do anything. And any other key needs to be filtered out of the equation. So I'm going to go ahead and import my global variable, which is current key. I'm going to go ahead and print up. And then I'm going to print the k.car. And then I'm going to set current key equal to nothing. Current key in my code stands for whatever key is being actuated at that current instance. When you're letting go of a key, you no longer have a current key, right? That key will be empty. That's what it stands for. And key down, we're going to program in the same logic, but this is going to be a little more complicated because we need to detect exactly what key is being pressed. So in this case, I'm going to go ahead and, again, call my global variable. Now, the reason you use this as a global variable is because this is going to be used in multiple functions that are outside of a scope. These are 2 separate functions so far, that are going to use current key, but they aren't located in the same scope. So they can't reference each other, right? It's like me trying to talk to you guys, like let's say outside a Zoom call, I'm trying to say something. Let's say I say to Vicky, I want a Hot Pocket, right? And she's like in her own home. She can't hear me. Like she doesn't know what I want. It's exactly the same thing. But if we call each other over the phone, which is like our global variable, and say, hey, Vicky, I want a Hot Pocket. And she says, okay, I'll get you a Hot Pocket. Then now both of our functions or both of our households know what's going on. Simple explanation of global variables, but they're really useful if you want to use a same variable in multiple functions. Just don't overdo it, because you can overdo global variables, and that's bad. So I'm going to go ahead and write an if statement here. When I press the key down, I need to detect a few things, right? So I'm going to say if my current key is equal to k.car, pass. I'm going to do nothing. If you've taken any of the digital logic courses and you know what synchronous circuits are, this is basically a flip-flop, a very software-based flip-flop, right? So if my current key is not equal to k.car, then I'm going to go ahead and print down k.car. I'm going to set my current key equals to k.car. And then I'm going to run a command called send command. And I'm going to pass in my current key. Okay, let's go ahead and decipher what this means. This is more or less some kind of coding logic that's really important, because we don't want our command to get run over and over again. We want us to press a key, and then as long as that key is pressed down, it's going to be running the same command once. So when I press a key S, I want S to be sent through the socket. I don't want S to be sent through the socket. That's going to be like really redundant, right? And really time consuming for the processor. So we got to press once. We got to press once only. And that's what this says. We assign current key to whatever it's being pressed right now. K is going to be passed in as the object of whatever key is being pressed, right? And we're going to assign that to current key. So if the current key is what's being pressed, it's not going to do anything. Key down will be called whenever we press a key down, and key up will be called whenever we release a key, right? So that kind of logic is really important. It's like a flip-flop. So please understand it. Very useful in other applications too. If you want toggle buttons. So if you've ever played Minecraft and like know what an RS NOR latch is, it's basically a latch in which when you press a button, you know how when you press a button, it goes like on and off? When you press a button, something happens. And when you press a button again, something else happens. So it's saying like if you press a button and the light turns on, and you press a button again and the light turns off, you know that button has a digital reading of 0 and 1. So if you're pressing it, you're actually toggling it between 1 and 0. So there's kind of your toggle logic. In hardware, it's sequential logic, it's flip-flops. It's a way of the computer store memory, actually, as to memorize what it did before and to do things based on that. In more complex terms, this is a control system, a feedback control system. So in this case, I'm finished with that lecture. We're moving on to send command. So I want to go ahead and send some commands to my server in this one here. So I'm just going to go ahead and copy this code and paste it down here, and that'll be it. So notice current key is a global variable, but I did not call global current key in this function. Why is that? It's because current key is only being referenced and not being changed. In Python, you only need to list a global variable inside the function if you're going to change it. If you're just referencing it, you don't need anything. So note that I'm sending, right, through the socket. Whoop. I'm going to send the word up, left, down, and right based on, what key is being pressed. Bunch of if statements. As I said before, machine learning is just a bunch of if statements. And if the key is not one of these keys, it's not going to send anything because this is not one of our commands, right? We said WASD, not J or L or O or P or something else, right? So in that case, we're basically done. After one more thing, we have to bind our keys to the tkinter window. So just like how we have to bind our main canvas, we also have to bind our key presses to our main can, which is why you can only control the car or control the robot or send the commands when you're clicked into the tkinter window. Other than that, you can't. But based on this logic right here, we should be complete. Our server and client now has all the code and all the logic required to talk to each other, which means the client can send logic to the server and the server can send logic to the client. Let's see this in action. So I've had the server running for a long time now. We need this running right here. Let's see. I'm going to go ahead and open this. Right. I can't. Because remember, clients can have all different kinds of IPs. So in this case, I have to do Python 3 client.py. And my host ID, which is 127.0.0.1. Now, this is my example of a failsafe that prevents you from basically running with any old IP. It's a protection measure, basically. So let me go ahead and run this. Okay. It crashed. Lovely. Okay. Now let's see why it crashed. So we can see that it got the connection, right? It also started the server control function. And then it started the client data retrieval thread, but then it stopped there. So what happened now? What code did I mess up on? We checked the data received client because that's where the data is coming in, and that decodes it. But also it should be sending data over to. So in this case, it must be something within our update data here. So within our update data, are we missing anything? Should be receiving it, and then should be splitting it here and then just assigning it all to the values. Let's see. Let me go ahead and try again. So it listens, right? And then I'm going to go ahead and update the code. Okay. I just didn't update the server. All right. Here's the final part of this very long workshop here. When we open the tkinter window, we can start to see all the data points updating, right? It's just a bunch of numbers for now, but in the real thing, you're going to have real data points coming through. You can see the server is trying to find a client, but it can't because there's no clients. So it's going to try again, right? I think it actually timeouts after a while. That's why it didn't work the first time. But now we can see all the data coming through. It updates every 50 milliseconds, so you can see all the numbers parsing. And bonus points, we can go ahead and press the WASD keys, right? You can see up W. Send command takes 0 positional arguments, but 1 was given. Okay. Yes. Okay. Let me go ahead and restart this. All right, 3rd time's a charm. I'll wait for this to reset now. Control C. Okay. So what we want to see is, there we go. We have up inside our server, and then it says down W, up W. So we pressed on W and we released W, right? So then we can do right. Oh, we have to click on the tkinter window. So right, left, and down. Now, I'm doing this all on the same computer, but just understand that this will work on a Raspberry Pi. It can work on your computer too, but that's a lecture for another time. Maybe if I do Python 5, we can talk about the server VPS and how we can connect our code to that so that I can host a server on my computer and then any client from anywhere in the world will be able to connect to it. It's a little unsafe, but we're just doing basic data transfer here, so it should be okay. If you want to be more safe, you can encrypt the data, but that's also another lesson for another time. But as for right now, this is basically how you can like control a robot, by the way. You just feed the Raspberry Pi data into like an Arduino and just like start controlling it. But right, left, up, down, right, left, up, down. It's pretty instant too. Like if you look at this command prompt and you look at the terminal down here, it's pretty instant, right? It's also pretty instant because it's my local server. So there's like 2 milliseconds of ping. But if you were to connect your client to my server, it would be about 20 millisecond ping based on your location. All right. So that's the script. And I can go ahead and I know it works now. So I'm going to go ahead and close and then close this. And now we can complete the project by going ahead and uploading it to GitHub. So I'm going to go ahead and find an emoji. So like a check mark emoji. I really like doing these with GitHub updates because it makes the repository look real nice. I'm going to say code from server clients code please. And I'm going to commit to main. And I'm going to publish my repository. And I'm going to just click publish. Okay, it was that simple. We're done here. So now we can view on GitHub, right? And then we can see that our client.py and server.py code are complete. And we click on here, we can see that everything is color coded. Everything's really nicely written down. So is the server code. And we also have also have the MIT license here too. If you look at more detail as to what it is, it permits you to use this for commercial use, modification, distribution, and private use, but limits your liability and warranty on it. So that's about it. Let me go to the PowerPoint. And I'm just going to go ahead and breeze through this figure here, which I think is very important, real quick. So this is our Hyperloop system, but more importantly, what we talked about today was the relationship between our server and our clients, right? So our server, which is up here, it's represented using a cloud because this server, in actuality, manages the communication between the Raspberry Pi and our client RPi. So you can see here how our client.rpi connects with our server, right? It has a wireless connection to a server that is located on the cloud. And our clients are also connected to the server. We can have multiple clients, but we need one Raspberry Pi. This is where our pod is located, right? This is a Raspberry Pi. Over here in the red, these are our Arduinos. Arduinos control where the sensors are, and we can communicate between Arduino and Raspberry Pi through serial. So this is where the Arduino data goes in, Arduino data goes in, Arduino data goes out, and all of this works together to produce for us a way to start the pod from our ground control station, stop the pod, turn on the brakes, test some functionalities, and also receive all the data that's coming from it. Again, we're interested in bi-communication or two-way communication, so we can receive the sensor data and provide controls to the pod to turn it on and stop it and whatnot as well. So in conclusion, really useful software to know and learn about. We learned about socket. We learned about tkinter. In socket, we learned how to establish a client socket server client relationship in which the server we can set up and set in the cloud. We created a loopback and feedback system in which the server continuously polls for clients. And in client, we created a tkinter window in which we are able to get data from the server and also provide the server with some commands, some controller commands in the form of WASD keys. That's pretty much it for today. So does anyone have any questions?
Not really. No, pretty much straightforward in a sense, but
Yeah.
I do actually.
Oh, sorry, Addie, go first.
Yeah, sorry, was someone else talking?
No, it's just Vicky was very close to the camera.
Oh, okay. Trying to find it right down. There's one part where you're looking at error messages, and it was like error, and there's the E, right?
Mhm.
But I only saw you type in one error message. Where do those usually come from if it's not defined by the decoder?
So your question was on this one, right?
Yes.
Okay. So when you're coding, right, this is a very specialized version. When you're coding, you might not know where the data, where the error comes from. It can come in from a lot of places. Like you can have a typo, you can mess up on a list instantiation, there's a billion different reasons, right? And instead of stopping your code, what programmers will do to debug their code is actually just encase their script inside a try catch block and then print the error message. So
right,
what you can
go on.
Yeah, go on.
I'm saying the computer is supplying those error messages, right?
Yeah.
So is this the E? Oh, I'm just trying to figure out where you're invoking the computer's ability to produce error messages, I guess.
Well, anything inside the try catch block can throw an error. Like if I go ahead and misspell RECV and I spell REV, right? It's going to throw the error as I don't know what that is, right? So if it throws an error in here, it's going to tell me what it is because that's part of the compiler. But sometimes it's going to be like there's a lot of errors inside my code and I don't know exactly where it is. So I can put part of it inside try catch blocks and then print out the error message. And if my code stops somewhere else, then like I know that it's not a problem, right? Exception SE is really useful for targeting errors because like I can't really display it here because I already have all the code. But when you're actually writing custom code yourself, especially in Python, you would use exception SE to find out where you made a mistake if the compiler itself isn't specific enough.
Okay, thanks.
Did that answer your question?
I think so.
Okay. All right. Victoria, got anything else?
No.
All right. Well, if that's it, then thank you so much, everyone, for coming to today's workshop. I know it was almost an hour and 40 minutes long, but I hope you guys learned something. Hope you guys had a fun time here. I'll go ahead and put this presentation in the GitHub on the video when we send it out. And to those of you who are watching and you've made it to the end, glad to see you there. But thank you so much for watching. And I hope to see you in the final workshop of our semester, which is Arduino 2 in 2 weeks.
Thanks, Chris.
Yay.
Problem.
Thanks,
Thank you, everyone.